upgraded as well to the slideshare.net. You should go to slideshare.net/ydm. So you'll again find all the previous slides and the current ones right there. We're going to record these sessions, so I will request you that in case you want to talk, network, please use the space in the back or the outside. We have our system right in the middle, so just make sure that we don't disturb that one. Oops. Okay. And just like all time, we would like to make this more interesting for you, more useful to you. So in case you come across any interesting topic, do let us know directly on the Meetup page or write to us directly at hub-meetup@yahoo-inc.com. So we'll look forward to that. And 2 weeks back, we launched our new Hadoop blog from Yahoo. If you are interested in learning about the history of the Hadoop and what's happening currently, and what's also going to happen in the future, this is the best place. So go to yahoohadoop.tumblr.com and you'll see a lot of interesting blogs right there. All right. So time to get started. My first speaker is Steve. Steve is currently a member of technical staff at Hortonworks. Steve has been working on the Hadoop area for quite some time now. He's also the author of the book called And in Action. Before coming to Hortonworks, he was at the HP where he worked on to the distributed configuration management. He worked on to the virtualized Hadoop, and he also worked on cloud infrastructure. So quite knowledge in that place. At Hortonworks, he's working on one of the incubating project called Apache Slider, which has a promise to help any user to build apps directly in pop-up Beyond. So, to learn more about that, please welcome Steve.
Hi. I'm Steve Upper. I like to break large things, which is good, but unfortunately I've just broken my laptop today and I probably won't get demos, okay? Maybe later, but no demos, so you have to trust me when I say it all works, and if not, you can download it later and show yourself. Now, hands up who wants to hear about Slider? Hands up. Hands up want to hear about distributed correctness proofs using Lamport TOH algorithms. Because I know the rest of you wouldn't come, but it's really important here. So we have a choice here. Theoretical computer science, something shallow without a demo. Choice? Right. I'm working on a project under incubation called Apache Slider. And its goal is driven by the way the world is changing, that modern applications are different. In the old days, you'd have a little 3-tier web application with MySQL in the front and Apache on the top. Now, you've got so many different devices and phones and web apps and feeds talking to your application. You've got a log layer underneath, which is becoming Kafka's becoming nearly pictures now. Something up there that has actually got a real application. And that's something that's kind of being neglected. So yeah, we have classic Hadoop there, whatever stream application you want, whether it's something like Sandbox or whatever. You can use HBase as storage, but this little bit here, the application has been neglected because really, this application needs to be running near your data in your Hadoop cluster because it's so linked up to it. And it's something, everyone ends up writing their own custom applications. Well, that's good, it's hard. As well as the code problem, there is the problem of just getting it all to work. And a lot of it's operational. It's finding machines, it's installing things, configuring them, managing your application, just starting and stopping it, reconfiguring it, that kind of stuff. So it's operations. And more particularly in this world where you're sharing a cluster, it's dynamic operations. So what we're trying to do is automate some of that, make it possible to deploy your apps in a cluster. Keep going. Your code, your Hadoop cluster. So, hands up, who knows what Apache Yarn is? Keep your hands up if you've written a Yarn application. Nobody. Well, someone interested there. Stick your hand up high if you enjoyed it. The problem is that it's a great concept. It says here is a way you can run all your code across a cluster. It's complicated to get working, and the other thing is reliability and dealing with failures is one of the hard problems. It's just things go wrong. It's actually not too bad if you're writing a short-lived application to last a few minutes, a couple of hours. Things may not go wrong. We've been trying to do things that run for months and discover interesting failure modes and the joy of Kerberos tokens. So, as background, Yarn runs your cluster. You have your machines, HDFS, your Yarn node manager, and space for work on the screen. When you actually want to run something, your little client application sends a message to the resource manager saying, give me some space. Somewhere out there, Yarn app master, Yarn deploys your code called the application master. That's the successor to the job tracker. It's kind of equivalent, but it does whatever your application does. For things like MapReduce, it's the successor to the job tracker. For Tez, it kind of manages the workflow. The slider, we're using it to manage other applications. Anyway, your application master comes up. It sends a request to Yarn saying, give me containers with some requirements, where requirements are currently memory and CPU. There's no reason why it can't be extended to hard disk allocations, GPUs, that kind of stuff. You get your containers back, and it's up to you to decide what to run on it. You effectively build commands to the exec at the command line with whatever binaries you want downloaded from HDFS. When they run, they run. When they finish, you get told. If they fail, you get told as well. So it's up to you to decide what happens when things fail. So, Apache Slider, its aim is to try and make it easier to run existing applications in a Yarn cluster without having to write your own application master and deal with all the problems they experience. So, what we have then is we've tried to be more declarative in how we work with code. So, we have our own Slider application. Anyone writing apps, they have an app package, which is it's a zip file with various bits of metadata and Python scripts, which you hand off to the CLI to deploy, along with 2 JSON files, one of configuration data, one of deployment information. Maybe animals, let's see. So send it to the CLI, and it starts up the AM, which then it takes a description of what it wants, a JSON file saying, I want 2 HBase masters, 3 workers, and a thrift server. It compares it with what it has, and if it has 0, it will go and ask for them all. If it has less than it wanted, it goes ask for some more, which is how it reacts to failure. If you startup and recovery from failure is the same problem. It gets containers back from Yarn. On each container, we start a little Python agent up here, which then reports back to the application master. It reads in its configuration plan from where we store HDFS. It goes to the app master and says, I'm ready, what do I do? And the app master tells it what to do. It effectively gives it configuration information, specifically binding information to other bits of the application. And says start, and they start running. If they don't start running, we worry about that. If there's any problem, we just kill the container and restart. We don't try recovering. If it fails too often, we say, this is broken, we'll stop running it again. The reason we do that is I left the test cluster running over a weekend, being continually started and stopped. It generated many gigabytes worth of logs, so now we give up. The code running at the far end, it can generate configuration information, the final binding of stuff. Key one being ports. You don't know what ports your application is going to be up on, you better tell it. So what happens is the agent does all this stuff. It tells it back to the app master saying what's going on, which then sticks it up somewhere. And currently, what is as of this week in 2.6 is it goes into the Yarn Registry, which I'll talk about later. So that's basically it. You give Slider a description of your application, which someone has to put in the effort of doing. That's the hard one. A couple of JSON files saying what you want, and issue the commands to actually bring it up. The application package, it is a zip file with bits of metadata. There are various XML files, bits of JSON, effectively some template. The resources says what is my yarn layout, and my config is my template config. Inside the XML, the XML is not typically some XML, junk, XML. Key on being different roles, like I've got something in the name of Nimbus, its script is Python script to it, and how long to give up. It doesn't work. You have a large collection of Python scripts. Each one effectively has a start and stop commands for different roles. We're using Python because it's lightweight, it's a bit brittle against versions, but it does run most places. It runs on Windows as well, we run on Windows. And at the actual level of machines, we're not trying to be dictatorial about how you're really doing your configuration management. We're not saying, you must use Unity, you must use Chef, you must use something else. All we say is, you run a piece of script with the configuration data you provide. And here for Nimbus, we have some start and stop commands. Some raw metadata. Staring at this one, trying to think what happens. Right, so this is actually some of the metadata saying for HBase, we have various things. It says we're actually exporting something, say an API, JMX, with the value our HBase master host gets filled in. We've got some dependency declarations, and we actually say for HBase master run this script. So what that tells the agent is what roles to create, what commands to tell the agents to do when they run, what information to glue back from what the agents provide to actually produce all your binding information, such as here the host and whatever port got defined. And that's what we give upgrade users. The fun thing becomes in what you can configure. So this is effectively how you define your application. We have a couple of JSON configuration files, one of which says we're defining what our app looks like in terms of yarn resources. I'm saying my HBase master has 1 gig of RAM, 1 vCore, and I want 1 copy of it, 1 instance. The region servers, we're also saying 1 instance here. There's all the other details. So we can just add different numbers, different counts. We can also change this file in the running application. You can rewrite it in HDFS, send an event to the application master, and say, reread it, reconfigure yourself, and it flexes the cluster. So we can manually expand or shrink a running application. For HBase, it doesn't really make sense to shrink it. Well, it does, but it's kind of expensive. Let's say you got an application that's being more dynamic and reactive to mode. You could actually do it this way. We are not trying to be clever and actually do it based on load. If you talk to the Helix people, they've been doing a lot more live load monitoring and reacting to it. We're avoiding that for now. Larger and less elegant is our application configuration. We divide that into kind of global state and configuration options for each role with property expansion, and that's primarily it. So here we have some of our HBase site. We're saying, let's find the interesting value. Okay, so our HBase site is Zookeeper quorum is coming from a variable Zookeeper host. That's going to have to be defined somewhere, and when you configure the application, it will make its way down. And this all stuff gets interpreted client-side by the Python, gets expanded. As a result, any application in the Python script can decide what config files to create. In other words, you don't have to be constrained to classic XML configs. Anything you can set up commands will do, and you run it. And the answer is that for the applications we've got working so far, Cumulo, HBase, Storm, Memcache, it seems to be sufficient to work this way. Now at this point I would give a demo. It wasn't working earlier. I might give a big demo now. Let's see if I can give a demo. Second. Let's do demo. Here is a Hadoop cluster. It was running something, and now it's not. I'm not going to run the real command line because that wasn't working. I'm actually just going to run one of our functional tests, and that's going to deploy something in the background. If people haven't seen this, this is the yarn status view of what's going on. Normally it indicates progress, how far your application is doing. We have a different notion of progress. We have up and down. Or more subtly than that, we have what percentage is available. In a very large application, you never have them all there. Here we go. That's fine. Let's leave it running for a minute and check. We'll talk about what's happening then. So, Slider takes the configuration documents, your zip file. It uses yarn to copy them down to the target machines. It says deploy the zip file, which then gets expanded within the scripts. In there we have things like HBase tar. They get downloaded. The scripts actually exec the commands, build up the configuration through prompt expansion, then exec the commands to start it. Some of the scripts, I'm pointing to the Storm ones, do more complicated things as they're trying to find free ports. Finding ports is a real problem as well because you can't hard code ports into your app or they won't deploy very well. You can't really pre-allocate them very nicely, so we have to find them dynamically. They get run. Slider just keeps an eye on what's happening on the cluster. It says, okay, I have 3 workers, 1 master. Everything should be happy. If you get any failure events from yarn, like the container goes away, it just reevaluates itself and says what to do. If the application master stops itself, it gets killed, it restarts. So the application will keep going. There is no real single point of failure in the system. This ability for app masters to restand failure is kind of new, and we have to go away. We have to do it by being completed status. Anyway, so my app is now deployed. It's running. Let's go to this app master window to see actually what's happening there. And I'm not actually deploying any interesting application right now. Okay? This is one of the test ones that does nothing. It basically echoes and sleeps and control the fail. I will have a look and see if what our REST APIs are publishing, which we should be publishing some configuration information. They're saying, right, we're publishing, our app is publishing all its dynamically generated state. I can just copy the part into a REST API where I say, give me that. There's an HBase site, and I'll put XML, and I get an XML file, which is exciting. I'll point out if we put JSON, we get it rendered as JSON because we're not. It doesn't really matter what application wants to use this stuff. We're trying to publish all the data, and this is generally dynamically generated stuff. In this particular demo case, it's not doing much. We're also publishing it on the registry, which I mentioned. I'll get back to in a second. One of the real problems in this world is that things move around and we can't predict them. Everybody ends up writing a registry. If you have a look, the curator has had one hacked together. We all tries to do one. We're trying to do one here. We did a first couple of iterations in Slider, and finally we decided that we've learned enough of our lessons to actually say this is what we want across the whole of yarn. Which I have just about done. It is a complicated path here, but if you look, I'm sorry, it's ignoring the rest thing, it goes users, eval services, or Apache Slider, and then the name of my application, which is happy path with effects. That's actually a DNS path. It's not just a REST URL, it's a DNS path. So we have secret plans in the future to serve this stuff up onto DNS. And it's just, I'm publishing a service record that says, here's my application master, here are the endpoints I'm offering the world, my IPC API called Raw Apache Slider App Master, running on port 390, 407 is my name node, and I've got a web UI and various REST UIs. So I'm publishing this information, and I'm publishing it under Zookeeper. That's pretty much what I'm going to show you this demo actually. We can start and stop, freeze and thaw, do things like that. The test will get confused by that. The registry stuff I just showed you is a profound new feature coming in Hadoop 2.6. I checked it last week. Even though it's built around Yarn, it is not restricted to being Yarn specific. Our goal is pretty much all applications running a Hadoop cluster should be registering themselves. Not just so that other applications can find each other, but so we can publish our config information. One of the real pains of Hadoop applications is just finding out things. Fault setting, class path, replication factors, all that kind of stuff. We've automated a lot of the cluster configuration side of the thing in cluster, but we've just neglected the end user applications. So what we're doing right now is we've got the Zookeeper core for publishing your endpoint bindings. We are going to be evolving it and iterating it to publish more config stuff, and doing that over a REST API that's designed to work over long distances too, using the NOx kind of security thing to follow your stuff through. So the plan is there's no reason why your Yarn cluster running somewhere in somebody else's cloud infrastructure, you, your client, can't connect to whatever HTTPS, list what services and their configuration information are, and then go and talk to it. So this is very good. It's independent slider now, be in Yarn, so if you're writing Yarn apps, I would say, look at this code and enjoy it. And it's also where that little bit of formal mathematics came from as well, as this is about the first piece of Hadoop is actually being rigorously specified, although it still has tests that don't work. Something to do with security again. Anyway, we have a CLI, which you haven't seen working. We have tests. We also hook up to management tooling. Although we'd originally envisaged saying, yes, this is a CLI application, the first few people that picked it up and were using it internally were actually using it behind their own web applications to say, we've got a web view where we can talk to somebody, press a few buttons, and bring up a very small HBase cluster on the bottom, or Cumulate cluster. Not for production use, but more just proof of concept. Let developers run their little test apps in the clusters with the machines you've got to spare and the data you've got available, and see how they go. Well, what my colleagues have been doing is actually saying, how do we make sure that Slider can also hook up into management tooling? So what we've done is we've added a way to bond it to a management tool. This is not, we've done it for Apache and Bari, but it is not exclusive to that. What really happens in this world is that when the Slider App Master comes up, instead of telling the agents to report to it, the agents report are given the URL to talk to management tooling. Bari. It's actually collecting all the information, including monitoring stats and alerts and things like that. And it's relaying the commands from the app master. So it fits in the middle, it knows what's happening and has some control. But it's still using Slider to manage the application state. Again, no demos. But this is a screenshot from this morning. My colleague says, right, well, we just have a UI that says I want to create an application. You give it its name, you can say which host you want it to be on, whether it's specific or general, and whatever parameters you want. That gets created, and then you will have a view of what's happening. So this is somebody's deployed database. That is pretty much it as far as the demo goes. I will point out that all the code is there. These are my colleagues. These people all do things that work. That's me. I'm the one that takes the blame and doesn't. There's another photo where they were pointing at doing the same thing. So, I think we're just making a start here. This is, we've got a framework where we can now deploy different applications in a Hadoop cluster. Away from just saying, yes, we've got analytics, yes, we've got HBase, we can now do the things on top of it that talk to it. We have to go beyond that and start thinking, okay, well, how do these things move together? If I'm going to deploy a set of Kafka nodes, I'm going to deploy HBase, I want to deploy an application, I want to bond them together with Registry. But you have to start looking at applications as an aggregate set, of a set of different applications. And I think that's going to be an interesting area to work on, is how do we glue together big applications from little ones. So, first thing we do is get Slider out the door, get people writing application packages. If you want to do that, I would encourage you to get involved, get on the developer mailing list and come and ask us questions. And we're going to start working at that level, but we need to think, where do we go from there? The other thing is actually is Docker, if you have a lot, because it changes how you deploy stuff. You stop having to untar files and configure it, hoping that the external system is correctly configured. And now you're just saying, right, push out these app images. And all you're doing is making sure the configuration for the images is kind of consistent too. So we are having fun out here, and it's open source. We encourage participation. I think I'd also like to open up some of the tools, the application code, so other people writing Yarn applications can steal as well, because we've got to do it slightly better. People shouldn't have to write as much code as we have to get this thing working. And that's me, so who has questions? Okay, and the audience there.
So I just want to figure out what the main reason, not what main ideas for Slider. From my perspective, the main ideas for Slider, the first one, to bring everything in the same cluster.
So question, what is the main idea? The main goal is so that we can run other applications in a Hadoop cluster, where you can't choose what machines you've got. You don't know where they're going to be and what machines there are. You can run, you just ask for a set of resources, like say 4 hosts with, 4 processes on different machines with say 2 gig of RAM each, and you will get them somewhere. So it lets you run more code on a Hadoop cluster with analytics applications, partly because it's a set of machines, more interestingly because it's a set of data, and then when you have the rest of your application running there, like the data, like HBase in that, you're going to want to run the whole of your application next to each other. So it's to try and make it move your Hadoop cluster beyond just somewhere where you keep your data and your analytics to actually somewhere where you run your applications. Does that make sense?
Yeah, definitely. So the follow-up question actually on this one. So I didn't fully get it. So Apache Slider, the Slider App Master, it's one for all applications?
It's one per application. If I'm starting a copy of HBase, I bring up an HBase App Master. If I start a Cumulo one, it starts with a Cumulo App Master. If you start an HBase one, it starts as your account with your security credentials, and you can't read my data. Okay, so it's isolated that way as well. Another question?
So you said that you were avoiding paying attention to load. Is that just a short-term decision, or do you think that the whole slider structure is basically inappropriate for paying attention to load?
Paying attention to the load. Well, what we're doing is we're not paying attention to monitoring and reacting to load. Okay, so we're saying we're not doing things where we actually measure what, say, the queue length is in an application and saying, oh, we need to trigger resizing. There's no reason we can't do that. I look at where we're going. I want to do better liveness monitoring first to say, is this thing alive? Then we'll worry about load. And liveness monitoring is a matter of saying, we're going to take some of those published URLs and ports, start running probes against it and make sure it's reactive. Load, if you're publishing monitoring information the same way, because it's something reactive. The main thing is that to react to load, you've got to be able to come up fast and go down fast. Okay? And for a Yarn cluster, the ones we've been doing, the test ones is relatively fast. The more laden you are on the bigger applications, the longer it takes to come up. So I can't make any guarantees about how fast you can really react to load. So right now we're just saying you can do it manually. The other thing to think about is actually the problem of just resource conflict on the machines itself. If I'm trying to run something like HBase, someone over there is running an analytics job, is it going to impact? What we're going to have coming in 2.6 is the ability to label your cluster with nodes. So you can have different racks of machines. One rack, you could basically say production, label that production, and you say only this particular queue of Yarn of work can actually put jobs in there. So that way you can at least partition your cluster and say, right, with production, HBase systems, they're running isolated, they're not fighting for local disk of bandwidth the way you are for analytics jobs. We are still going to be sharing network, we are still going to be sharing the underlying HDFS fabric. So there is still some impact in there that we're quantifying. See what actually happens under heavy workload. And once you do partition your system like that, you've lost a bit of flexibility in placement. You've got more chance of idleness. So if you want to have excess capacity in production cluster, then that reduces the amount of compute other jobs you can run with it. That's the price of leaving headroom, isn't it?